Today, I'm going to talk about different VaR methods and their implementation. There are mainly three different VaR methods. One method is called delta normal, also called variance-covariance method or parametric method. The second one is called historical simulation method. And the third one is Monte-Carlo simulation method. Let's check out variance-covariance method first. This method simplifies the computation of VaR by assuming that risk factors are normally distributed. This is the formula you need to use when you calculate VaR with variance-covariance method. The first one is the investment amount, and the second one is standard deviation. And based on your confidence interval, you decide your z-score. If you have two assets in your portfolio, and then the portfolio volatility is calculated with this formula. And W1 is the weighting of the first asset, and the sigma 1 is the standard deviation of volatility of the first asset. And the rho is the correlation coefficient between the two assets. And if you have portfolio containing more than two assets, then you need to use this matrix to calculate the volatility or standard deviation of your portfolio. Another method is historical simulation method. With this method, you base your result on the past performance of your portfolio and make the assumption that the past is a good indicator of the near future. And there are several steps in this calculation method. And basically, you calculate the P&L vector for your portfolio for each time interval you decided. And then you sort the series of the portfolio simulated P&L from lowest to the highest value, and then pick up the number correspondent to your desired confidence interval. Another method is called Monte-Carlo simulation. This method is similar with historical simulation, but the difference is with historical simulation, you use data from the past. But with Monte-Carlo simulation, you use random number to simulate the market movement and then calculate the P&L vector. And based on those portfolio simulated P&L, you calculate your VaR amount. Now let's see where I got all those data. First of all, I got interest rate data from this FRB website. For the stock, I use Apple as the example. And for the stock price, I got Yahoo Finance. Now I'm going to show you how I calculate VaR for one asset portfolio with all those three different methods. Now, let's see how we can calculate value at risk for this one asset portfolio. I downloaded historical data from Yahoo Finance from May 22nd, 2018 to May 21st, 2019. For the horizon, I use 1 day. For the confidence level, I use 99%. First, let's calculate VaR with historical simulation method. After the calculation, we got this amount. It's about $10. If we switch to variance-covariance method, we calculate the VaR. It gave us about $8. And if we switch to Monte-Carlo simulation, in this example, I use 10,000 random numbers to generate different paths. After calculation, we also got about $8 for the value at risk. And for this risk-free rate, I use 2.5%, which is I got from FRB website. Now, let me summarize the advantage and disadvantage of each method. For the variance-covariance method, the advantage is the computation time is minimum and it's very simple. The disadvantages of variance-covariance method is because we assume the historical returns and the changes in prices of the assets follow normal distribution. If you have some nonlinear products in your portfolio, it's better not to use this method. For the historical simulation, the advantage is it computes quickly. It's easy to explain to people, and it doesn't need assumption about data distribution. But the disadvantage of this method is it assumes the future will be similar to the past, and also it requires historical data. If you want to start to trade a new product and you don't have any historical data for this product, it's difficult to use historical simulation. In that case, maybe you need to find a proxy for your new product in order to use this method. The advantages of Monte-Carlo simulation is you can use it to model nonlinear product, and it is not affected as much by extreme events. And you can use any statistical distribution for the calculation. The disadvantages of Monte-Carlo simulation is it's time-consuming and complicated, and it is costly to develop a VaR engine. This is my brief explanation about different value at risk methodology. Please provide your comments and subscribe to my channel. Thank you.